Today in this video we are going to discuss how to form a differential equation for a given solution. So basically we need to eliminate arbitrary constants from a given solution to form a differential equation. For example, if the given equation is y is equal to ax square plus bx plus c. So with the help of differentiation we have to eliminate these arbitrary constants to form the required differential equation. So if we differentiate it with respect to x, we get y dash is equal to, in the first term, a is constant coefficient, derivative of x square is 2x, so we get 2ax, and derivative of bx is b, and derivative of c is 0. And again, if we differentiate it, we get y double dash is equal to, derivative of 2ax is 2a, as 2a is constant coefficient and derivative of x is 1 and derivative of b is 0. So now only one arbitrary constant is left, so we need to differentiate it once again to get y triple dash is equal to 0. So this is our required differential equation for this solution. But remember one thing, that the order of the formed differential equation must be equal to number of the arbitrary constants in the solution, in the given solution. If suppose there are 3 arbitrary constants, so differential equation must have third order differential operator. If there are only 2 arbitrary constants, so the differential equation should have the second order derivative as the highest differential coefficient. And if there is only one arbitrary constant, we can differentiate that solution only once. Now let's start exercise 9.3. In each of the exercises 1 to 5, form a differential equation representing the family of curves by eliminating arbitrary constants a and b. So first one is x upon a plus y upon b is equal to 1. So as I said, there are 2 arbitrary constants, so we can differentiate this equation twice to eliminate these arbitrary constants. So first differentiating 1 with respect to x, we get, so first term becomes 1 over a, because 1 over a is arbitrary constant coefficient and derivative of x is 1, and in the second one, derivative of y upon b will be 1 upon b into y dash, and derivative of 1 is 0 because this is constant term. So now transposing 1 upon a to right hand side, we have 1 upon b y dash is equal to minus 1 upon a. Now transposing b to right hand side, we get y dash is equal to minus b upon a. Now differentiating again with respect to x, we get derivative of y dash will be y double dash is equal to, and since this is constant term, its differential will be 0. So y double dash is equal to 0 is the required differential equation for the given family of curves. Now question number 2, solution is given as y square is equal to a b square minus x square. So y square is equal to ab square minus x square. So y square is equal to, opening the bracket, we get ab square minus ax square. Now differentiating with respect to x, we get 2y into y dash by chain rule. On the right hand side, this term is constant, so its differential is 0, minus differential of this term will be minus 2ax, because a is constant coefficient and derivative of x square is 2x. So 2y y dash is equal to minus 2ax. Now 2 is cancelled by 2 and transpose x to right left hand side, we get y into y dash upon x is equal to minus a. Now in order to eliminate this minus a, we need to differentiate it once again. So differentiating with respect to x. So by quotient rule, we need to differentiate it. X as it is, derivative of y dash, that will be differentiated with the help of product rule. only this term y dash. So first term as it is, derivative of y dash is y double dash plus, now first function's derivative is y dash and second function as it is, so we get y dash into y dash square minus, now numerator as it is, y dash, derivative of denominator that is x, differential is 1, and divided by square of denominator that is x square. On the right hand side we get 0 because this is constant term. Now proceeding from this step, we need to transpose x square to right hand side, so it will multiply 0 and we get the left hand side x into y double dash plus y dash square minus y into y dash is equal to 0. So opening the bracket we get x y double dash plus x y dash square minus y dash is equal to 0, and this is the required differential equation for the given solution. Now third sum, given solution is y is equal to a e raised to the power 3x plus b e raised to the power minus 2x. Y is equal to a e raised to the power 3x plus b e raised to the power minus 2x. We may write it as y a e raised to the power 3x plus b upon e raised to the power 2x. Because exponent was negative, so we bring it to the denominator to make it positive. Now y is equal to, taking e raised to the power 2x as LCM, so e raised to the power 2x, and in the numerator we have a e raised to the power 2x into e raised to the power 3x e raised to the power 5x plus b. Transposing e raised to the power 2x to left hand side, we have e raised to the power 2x, y is equal to a e raised to the power 5x plus b. That will be equation number 1. So now we have made b alone without any variable term, so that by differentiation we can eliminate this one. So differentiating, so if we differentiate left hand side, we need to use product rule. First function as it is, derivative of second, that is y dash. Remember, y dash stands for dy upon dx, y double dash stands for d2y upon dx square. So e raised to the power 2x y dash and plus, now derivative of the first function by chain rule, its derivative will be twice e raised to the power 2x into second function as it is y is equal to a as it is, because this is constant coefficient and we need to differentiate e raised to the power 5x by chain rule, so we get 5 e raised to the power 5x, and this term is constant, so its differential is 0. Now in order to eliminate this a, second arbitrary constant, we need to make it alone, so that differentiating we can eliminate this term. We need to make it alone. So in order to do so, we should divide both sides by e raised to the power 5x. So dividing both sides by e raised to the power 5x. So proceeding from this step, dividing both sides by e raised to the power 5x. So first term will be e raised to the power minus 3x. When we divide e raised to the power 2x by e raised to the power 5x, we get e raised to the power minus 3x y dash plus 2. And if we divide e raised to the power 2x over here, we get again e raised to the power minus 3x and y as it is. And on the right hand side, we get 5a. Now differentiating again, we get, here we need to use product rule because there are two functions. So first function e raised to the power minus 3x as it is, derivative of the second function, that will be y double dash, and then plus derivative of the first function, that is e raised to the power minus 3x into minus 3 y dash as it is, second function as it is. And in the next term again we have to use product rule to differentiate it. So 2 e raised to the power minus 3x as it is, derivative of y is y dash, and plus derivative of first function, that is twice e raised to the power minus 3x into minus 3 y as it is as second function, and is equal to derivative of 5a is 0 being a constant term. Now finally we have to simplify this, e raised to the power minus 3x y double dash, and these two terms are identical, so we have to simplify them. This one is minus 3 e raised to the power minus 3x y dash, and this is twice positive 2 e raised to the power minus 3x y dash. So negative 3, positive 2, 1 negative e raised to the power minus 3x y dash is left, and this term is written as it is, that is minus 6 e raised to the power minus 3x y is equal to 0. Now, in order to simplify, just divide both sides by e raised to power minus 3x. We get y double dash minus y dash minus 6y is equal to 0. And this is the required solution, differential equation for the given solution. Now, fourth sum, given solution is y is equal to e raised to the power 2x bracket a plus b x. Y is equal to e raised to the power 2x a plus bx. Now transpose e raised to power 2x to left hand side, it becomes y e raised to the power minus 2x is equal to a plus bx. Let it be equation number 1. Differentiating with respect to x. First function as it is, derivative of the second function by chain rule will be e raised to power minus 2x into minus 2, and then plus derivative of the first function, that is y dash, and second function as it is e raised to the power minus 2x. On the right hand side, derivative of first term is 0 because this is constant term, and derivative of the second term will be b, as b is the constant coefficient and derivative of x is 1, that is b. So now we may write it as minus 2y e raised to the power minus 2x plus y dash e raised to the power minus 2x is equal to b. Let it be equation number 2. And differentiating equation number 2 with respect to x again, we have to use product rule. So first function minus 2y as it is, derivative of the second function by chain rule e raised to the power minus 2x into minus 2. Then plus derivative of first function, that is minus 2y dash, and second function as it is e raised to the power minus 2x. Next term is y dash e raised to power minus 2x, and its derivative will be carried out by product rule again. So first function y dash as it is, and derivative of the second function by chain rule e raised to the power minus 2x into minus 2, and plus derivative of first function, that will be y double dash, and second function as it is e raised to the power minus 2x, and on the right hand side 0 because this is constant term and its differential is 0. Now proceeding from this step, we have to simplify this. Just when we open up this minus 2 will multiply this minus 2 becomes 4 positive, and 4 y e raised to the power minus 2x, and that is minus 2 y dash e raised to the power minus 2x. Next term minus 2 y dash e raised to the power minus 2x, because this minus 2 will multiply this plus 1, so minus 2 plus 1 is minus 2, and third term is plus y double dash e raised to the power minus 2x is equal to 0. So we may write it as y double dash e raised to the power minus 2x. After that, these two terms are identical, so may be added because they have the same signs. So minus 2 becomes minus 4 y dash e raised to the power minus 2x, and this term in the last plus 4y e raised to the power minus 2x is equal to 0. So we can divide both the sides by e raised to the power minus 2x to simplify this. So we get y double dash minus 4y dash plus 4y is equal to 0. So this is the required differential equation for the given solution. Fifth sum is, given solution is y is equal to e raised to the power x a cos x plus b sin x. Y is equal to e raised to the power x a cos x plus b sin x. In fifth sum, the given equation is y is equal to e raised to the power x a cos x plus b sin x. So first we need to transpose e raised to the power x to the left hand side. We get y e raised to the power minus x is equal to, on the right hand side, a cos x plus b sin x. Now we have to divide both sides of this equation by sin x. On the left hand side we get y e raised to the power minus x cosec x is equal to, on the right hand side, a cos x upon sin x becomes cot x plus, here only b is left when we divide it by sin x. So let it be equation number 1. Now if we differentiate this equation with respect to x, this constant term, that is arbitrary constant b, is eliminated. So differentiating with respect to x, we get, here we need to multiply product rule. First function derivative is y dash, and second and third function as it is e raised to the power minus x cosec x plus first function as it is derivative of the second function, that is minus e raised to the power minus x, and third function as it is, and then plus first and second function as these are, and we have to differentiate cosec x, that is minus cosec x into cot x. On the right hand side we have a, and the derivative of cot x is minus cosec square x, and derivative of constant term b is 0. Now proceeding from this step, if we simplify, we get y dash e raised to the power minus x cosec x minus y e raised to the power minus x cosec x and minus y e raised to the power minus x cosec x cot x is equal to minus a cosec square x. Now dividing both sides by cosec square x to make minus a alone, in order to eliminate this, dividing both sides by cosec square x. If we divide first term by cosec square x, we get y dash e raised to the power minus x, and if we divide second term by the same, so we get, if we divide first term on the left hand side by cosec square x, we get y dash e raised to the power x into sin x, because if we divide cosec x by cosec square x, we get 1 upon cosec x, and 1 upon cosec x may be written as sin x. So in the same way, in the second term we get y e raised to the power minus x sin x, and in the second term minus y e raised to the power minus x. Here we have cos x, because if we divide cosec x by cosec square x, we get sin x, as in the first and the second term we have done sin x, and then we may write cot x as cos x on sin x. So sin x in the numerator and denominator will be cancelled, and we get only cos x. So y e raised to power minus x cos x, and on the right hand side only minus a is left. Taking e raised to the power x sin x common out of the first two terms, we have inside the bracket y dash minus y e raised to the power minus x sin x, and second term, third term becomes the second term, y e raised to the power minus x cos x is equal to a. Now differentiating this with respect to x again. Now proceeding from this step, if we differentiate first term, so we need to use chain rule. So differential of the first term is y double dash minus y dash. Second and third as these are e raised to power minus x sin x. Now plus first function as it is y dash minus y. Derivative of the second function, that is minus e raised to the power minus x, and third function as it is. And finally plus first function means the bracket y minus y dash as it is, second function e raised to the power minus x as it is, third function, derivative of the third function will be cos x. Now the next term is y e raised to the power minus x cos x. Same way we have to differentiate it using product rule. So derivative of first function is y dash e raised to the power minus x cos x. Because of this minus, all the signs inside will be negative, so minus second function as it is, derivative of e raised to the power minus x will be minus e raised to the power minus x, and cos x, third function as it is, and minus first function and the second function as it is derivative of the third function, that is cos x, will be minus sin x. And on the right hand side, derivative of constant term a is 0. Now simply, first of all, we need to divide both sides, that is each and every term of this equation, by e raised to power minus x to simplify this. So we get in the first term y double dash minus y dash sin x. In the second term, we have this minus is left, minus into plus becomes minus, minus y dash minus y sin x. In third term, plus y dash minus y cos x is left, and when we divide this term by e raised to power minus x, we get minus y dash cos x, and this term becomes plus y cos x. The last term becomes plus y sin x equal to 0. Now proceeding from this step, now what we have to do, we have to take sin x common out of the terms having sin x, that is this term and this term and this term. So inside the bracket we have y double dash minus y dash. Here we get minus y dash plus y, and from here we get plus y sin x. And out of this term, and this term, we should take cos x common. We have plus, inside the bracket we have y dash minus y minus y dash plus y. Cos x is equal to 0. You see in this bracket, positive y dash and negative y dash cancelled, negative y and positive y cancelled. We get only the first term and the second term becomes 0. So simplifying the first term, we get y double dash minus y dash minus y dash becomes minus 2y dash, and plus y becomes 2y sin x is equal to 0. So transposing sin x to the right hand side, we get simply y double dash minus 2y dash plus 2y is equal to 0. This is the required differential equation. functions